Welcome to this session. We're going to be talking about power digitalization. So we are talking about everything that we are doing to meet the goals of power availability, sustainability, energy efficiency, and how important it is to have measurements and control points in an electrical infrastructure with smart applications to be able to optimize those aspects of a facility. So my name is Arnaud. I'm leading the digital power line of business within Schneider Electric. That's doing all this digitization layer, so software and artificial intelligence layer applied to power and energy management, as well as all the intelligent devices we need to be able to get rich data from the electrical systems and to apply controls to it. So namely production relays, metering, and other type of controller devices for the power systems. So pleased to be with you today. So we've assembled for you a great panel of participants for the today discussion around those themes. Starting with you, Matt, if you want to introduce yourself.
Sure, thanks, Andy. Good to see so many of you in the audience as well. I'm Matt Beveridge. I'm the Head of Innovation and Partnerships, and I work for the University of Birmingham. For those of you that don't know the University of Birmingham, we're a global university with a main campus based over in Edgbaston, which is in Birmingham in the UK. But we also have facilities as far north as Coniston in the Lake District, and more recently a brand new purpose-built campus over in Dubai. My role is pretty much exactly what it says on the tin. It's all about innovation and partnerships, and as a global university with 38,000 students and 8,000 staff members, we're proud to be a long-standing client of Schneider Electric, using a range of innovations and solutions from BMS right the way through to switchgear. So that's me in a nutshell. Thanks for having me.
Thank you, Matt. Over to you, Matt. Oh, sorry. Yeah. James.
Hello, my name's James Chase. I'm the electrical asset manager for Associated British Ports in Southampton. Associated British Ports owns and operates 21 ports across the UK. In Southampton, where I particularly look after, we're a major import-exporter for cars and automotive. Also quite big in the cruise industry. We've got 5 cruise terminals. So my role across Southampton is effectively the head of electrical, so I look after an electrical team of electrical engineers, electricians, and we try to manage everything from BMS's an electrical network, and do everything from planned maintenance, reactive maintenance, and of course trying to drive down our electrical consumption as much as possible.
Thank you very much, James, and then Pip.
So, I'm Pip Squire. I'm currently head of sustainability at ARC Data Centres, but I've been with ARC since before ARC was ARC, and employee number 1, and we've seen the business grow from 5 of us to over 100 employees with 200 side, and we've got over 100 megawatts of IT space delivered around the UK. And as part of that growth, I've been Director of Construction and Building, and I've been Head of Design, Innovation and Energy and Sustainability. But the whole ethos of ARC has always been security, availability and sustainability. That's how we started. Now it's sustainability, availability and security, and as a result of that, energy management and energy efficiency has been absolutely core to our business. And where we say no wasted watts, that's absolutely what we're aiming at, because whatever we can do to drive down the energy consumption in a data center helps everyone in this room. And I'm happy to open the discussion as we go.
Absolutely, that's what we are here for. All right, so just to again introduce the topic. So we are talking about problem space, which relates to energy cost. That's what's been driving a lot of action recently, to be very honest. And we're seeing through the different crises that have hit all our operations in general, that the energy bill have been skyrocketing. But even beyond that, a lot of volatility in the energy, so making it difficult to predict and plan the energy cost. Wasted power, in a very broad sense, we've seen things like power quality being issues. You have to produce reactive power to feed facilities which are not equipped in the right way. Cost of downtime is important, and restarting facilities. Obviously, it's a lot about efficiency of using the electricity in the facilities that is leading to, let's say, increasing problem space from that standpoint. And obviously, all of that usually without touching the availability of power. That's where digital solutions have been primarily designed for. Power availability, make sure the power is always on. So while we are trying to meet the other goals at the same time, obviously, critical facilities don't allow for any downtime, and we need to secure that the availability of power is remaining untouched, even when we want to introduce variable sources, variable loads, issues on the grid, and more complexity somehow in the electrical system. So when we do all of that, the target is really around usually 3 goals, overarching goals. The first one is efficiency. And so there is a question of energy efficiency, obviously, in the operation, and being more, let's say, nimble in the way we consume energy and managing the loads and the consumption of the power system itself. It's about the operations efficiency as well, and how fast can we restore power, how can we control better the installations to make them more efficient. Uptime, always top of mind, and I think what's maybe changing a bit there is that we used to be in a world where in the building space maybe it didn't matter that much. I think it's changing. So these are critical buildings like healthcare facilities where it's always been there, but with the evolution of buildings not just being a vertical distribution system in terms of electricity to flow down power from the grid to the loads, with more and more active power flow management. We're also seeing risk to the availability of power because we have more and more big variable loads like EV chargers, for instance. When you put 5 in a facility, it goes unnoticed. We are seeing tenders for large real estate companies where we have to have hundreds of charging points, which equals twice the average consumption of a building to fit this facility with all the chargers. So very heavy variable loads to be managed, coupled with on-site renewables. So this creates variability. This creates also power quality issues because of so many power converters. So this space is also changing in the sense that buildings are in need more and more to control power and manage uptime as well. And then last but not least, sustainability, obviously, there's a core reason of all these movements. So while we can work on the efficiency of the process, there is only so much we'll be able to reach. But we also need to be able to supply the processes with green electricity, which come with variability and a couple of challenges. But the overarching goal remains how we can lower the greenhouse gas emissions, the footprint. When do we consume energy from the grid when it's at the same time usually cheap, abundant, meaning renewable energy, which are variable by nature. So all of that is coming with more and more constraints on the way power flows are being managed in a facility. So we'll hear about real life stories from our guests here around that. And so when we maybe to start a bit and prime the pump on this discussion, I'm going to ask you a couple of quick questions, asking no comments, but just yes, I agree, you raise your hands. No, I don't agree, keep it low. All right, you ready?
Yeah.
Okay, so let's get going. So question number 1. So investment in power digitalization are a must for modern organizations. Okay, so that one's pretty easy, thank you for that. The role of artificial intelligence in power management will be growing as quickly as Internet of Things. Okay. So mixed feelings around it. Good. The outcomes of implementing a digitalization project in my organization is making a real impact. We'll put it like this. Okay, thank you. So different views from that perspective, that's great.
Yeah.
And I wish I had invested in the power of digitalization before, sooner. Okay. Any comments to that, Pip?
The reason I haven't raised my arm to the last two questions is purely and simply because we started doing that right at the beginning. When I first went to our investors back in 1995, what was going to be the difference between us and Equinix and all the other big data center players? And we need to say we need to be able to measure it, manage it, and prove it. And if we could prove the energy efficiency that we said we were getting, then we would be in pole position, and that has absolutely proved to be the point. That's why we've grown as fast as we've grown. So if I hadn't done that, we wouldn't be where we are today. So to me, it's an absolute no-brainer. If you can't measure it, you can't monitor it. If you can't monitor it, you can't manage it. If you can't manage it, you can't make it better. And in this world where everything is connected and where people don't actually know how much energy they're actually using when they use their phones and tablets, it's time we got real and started managing it all. But that to me is where I'm coming from, but it leads to my next point, and we'll throw the floor open, is when it comes to digitization, when it comes to managing and measuring it, the most difficult part on the whole journey is the starting point. What are you going to manage? Where are you going to manage it? How are you going to manage it? And why are you managing it? If you can answer those questions and build your management system around that, then you'll be in a really good place to be able to digitize it. If you haven't done that groundwork first, and my biggest problem at ARC has always been, what do we really need to measure? And what do we not need to measure? Because measuring and monitoring just for monitoring's sake is bad practice. You need to measure for a purpose. And if you understand what you're trying to achieve, that's the battle almost won. At that point, it's easy to talk to these guys and say, right, these are the bits I want you to do, this is where I've got it all measured, fix it. If you haven't done that, they will come and tell you, do this, do this, do this, and it won't work. So to me, you need to be able to you need to have a very clear end goal. What am I measuring, why am I measuring it, and how am I going to report it? When you've got those, it makes the rest of it easy.
So Pip, you've been growing a very innovative and company from that standpoint. Maybe turning to Matt first, in the environment you are in, university, which has a fleet of buildings, a lot of existing buildings, right? The building stock, in a sense, is usually mostly existing, not so many new builds, I guess. Probably inheriting very old buildings as well in the campus. So, what were your kind of starting points on implementing those kind of solutions? What kind of problems were you trying to solve?
So, firstly, I think the second point around the role of AI, I actually think it will overtake IoT. I don't think it will grow in parallel. I think it will overtake IoT. I think there is this conception and perception that is developing at the moment, which certainly from the conversations that I've been involved in with industry players, there's already enough equipment generating data. Actually, it's about turning that data into insight that can drive decision making for action, which was, of course, one of the key themes that I took away from this morning's keynote talk. From a University of Birmingham perspective, we've got a very large, complex and varied estate. We've got more than 200 buildings in our portfolio, ranging from grade 1 and grade 2 listed right the way through to new build. As a product of what we are and what we do, we're a civic university, so we're here to support the region and the national interests, specifically when it comes to education and research. 80% of our building stock that we have today is going to be with us in 2050. And when we've got more than 200 buildings in our portfolio, that gives you an idea as to the size of the challenge. From a digitalization perspective, there are perhaps two real key challenges that I'm experiencing at the moment. And the first is around the expertise and the competencies that are needed now in the modern age. We're really lucky. We've got a very experienced workforce at the University of Birmingham, so I'm part of a team that is made up of around 200 employees. Very experienced, very technical, but very traditional. And so the concept of digitization is something that still is quite alien to some of the team, especially when we're starting to talk about certain expertise that are going to be required moving forward. So a big part of my job from an innovation perspective is winning the hearts and minds and bringing people with us on that journey, because we can't afford to leave people behind, especially when actually there's a shortage of skills and expertise within the sector already. So it's great having the capabilities within Schneider to support us on that journey, but actually fundamentally there's more that we need to do to plug the skill shortage that I think is impacting all of us at the moment. Digitization, it will permeate through all aspects of business, and from a university we're not immune to that. I think the second is around the supply. Where we're based is just on the outskirts of the city centre that is Birmingham, and directly opposite us is the Queen Elizabeth Hospital. And for those of you that know the UK, the Queen Elizabeth is a huge employer. It's first in the region, but it has a power demand that is even greater than the university, which continues to surprise me. We need to get better at sharing infrastructure. We need to get better at collaborating with partners. Some of those might be partners that are sat in the room today, to ensure that there is a really open and transparent conversation about the long-term strategic view. And that is important for us, because we need to have those conversations early so that we can think backwards from there when it comes to working out the plans to ensure resilience, to promote efficiency, to promote reliability. Because we wouldn't be doing our job as a university if we were to take all of that power and to leave the hospital across the way short on supply. I think there's one final third point which I'm particularly interested in having a conversation around today, if not as part of this session, and this is around the kind of interconnection and integration of various decentralized assets that are now starting to spring up as part of the renewables agenda. Because as a large owner-operator, we need to have a portfolio view of all of our assets, both at a building level and actually within each of the buildings themselves. Adding renewable energy into the mix as well creates an additional pain point that we just need to be mindful of. Ideally, I'd like to have one platform and one portfolio view that allows me to dashboard very clearly to understand what we're managing, where we're managing, and how we're managing. And only once we've got that can we then make informed decisions around how we change our services in accordance with certain external factors that might be bringing with it additional pressures.
Okay, thank you very much, Matt. And so talking about skills shortage and transition, talking about the long-term planning of the power and energy flows into your strategy, as well as managing the day-to-day operation of what's becoming also a system with its own power generation, interactions with the grid, and your own loads, which become more and more valuable, right, as a synthesis.
And I think the role of partnerships, we firmly believe at the University of Birmingham that we need to work in partnership together. That's with others that are local to us, the QE being a great example, but together with industry, because we need industry expertise to support us on this journey.
Sure.
And that might be in response to our sustainability targets, or even just to ensure that we're providing the very best campus experience possible.
So turning to you, James, maybe can you talk a bit about in your kind of large infrastructure environment, what are the kind of the key challenges you've been facing recently?
I think the themes are very similar to Pip's and Matt's. I mean, I think we've got a challenge around sustainability, and then challenges around network. So obviously from a sustainability point of view, we want to drive down our electrical consumption. We've got 5 cruise terminals, we've got 7 multi-deck car parks, we've got warehouses, offices, all those sorts of things. And I think Pip hit the nail on the head. If you can't meter it, then you can't get the data, and if you haven't got the data, then you can't make meaningful insights. And I think a real challenge that we've come across is we've got lots of data, but trying to get all that data and put it into one place so you can make meaningful decisions is a real challenge, and having a platform to do that has made our life a lot easier. So from a sustainability point of view, I think it's all about metering, it's all about getting the right information and not making educated guesses about making the right decisions. But from a physical hardware point of view and from a network point of view, we recently installed the first UK cruise shore power connection in Southampton, which is where you can physically plug the ship in to the national grid, if you like, through the DNOs, and then they can turn their engines off. So it means zero emissions while they're alongside, which is obviously great for the cruise lines, great for the port, great for the city, great for the UK. But unfortunately, a cruise ship is like a small city, so it takes a huge amount of power, almost half of the power that we have in the Port of Southampton. So that has really driven us to think, right, we need to manage our power and be on top of our power. Because
So James, if I may ask, how often do you have to upgrade your power infrastructure in your environment?
Sure, so I mean, we upgraded it when we did the project to put shore power in, and now we, on an average day when we have shore power plugged in, we're probably sitting at 3/4 of our available capacity into the port, and on a day that we're not got shore power connected, we're probably only sat at like 1/4.
Okay,
So there's a massive driver when we plug a cruise ship in, so we need to be able to monitor in live time where our demand is and how we manage that. And I think the flip side of that as well is that now we can see in live time where our power is being used, and we can then make those meaningful decisions again to drive down that power consumption.
Are those operations mainly manually controlled still, or you have a lot of automation kicking in?
We've been on that journey. Probably in the last 3 years or so, we've recently installed power operations and power management expert. So now we can switch on and off of substations if we want to, or buildings, shore power on and off. But we want to install more shore power to continue that drive. We've got 5 cruise berths, we've got 5 container berths, and then many ro-ro berths for the cars, the roll-on, roll-off stock. So we want to roll out that shore power across all of our berths, but there's physically just not the power available in Southampton or the wider UK. So that's where we've got to be really smart about what we're doing, and hopefully with Ofgem changing the way that they're looking at distributing power, hopefully we'll be able to get a constrained connection, and then that means we can manage that power, and we can, something like shore power is perfect for that, because if they can tell us, oh, you need to turn off in 5-10 minutes, that's absolutely fine, because we can then relay that to the cruise ships, the ro-ro ships, the container ships, and then they can turn off, go back onto their generators, and then we can turn the power off and give that back to the city.
Are you also facing increasing regulatory pressures around the operation of the facility?
Definitely. So, I mean, there's always pressures from local council with emissions, UK. I mean, the cruise lines, well, all shipping is under massive pressure at the moment to reduce their emissions, as low as they can, and they're being rated now from when they leave their destination to their new destinations on it's almost like an EPC of how efficient they've been on that journey, and plugging into shore power makes that, gives them another tick in the box. So they're all really keen to do it, but unfortunately we just haven't got that infrastructure available to do it right now.
Yeah. Okay. So maybe talking about other type of critical infrastructure, Pip, do you want to tell us how much flexibility you have in your loads in a data center?
So the big difference between James and us is that we don't have real flexibility. Our power has to be on all the time, and therefore our systems are built to keep the power on all the time. But our biggest challenge has been, particularly over 2 years ago when we had the enormous price hike, and we saw electricity prices, well, for us, because we'd managed how we procured it, they only doubled, they didn't triple or quadruple like they could have done. But we had just bought on an 18 megawatt data center facility, and it was empty. So we had a lot of power being used to power an empty system. And we were able to use our power management system to basically say, well, actually, I can turn that off, I can turn that off, I can turn that off, I can turn that off. What can I turn off to be able to minimize my electricity bill? And then once I'd worked that out, I could then compare, how's this block comparing to that block? Why is this one not using it? Go away, find what this one was. So that, having that insight into where we were drawing our power enabled us to halve the electricity bill on that one building alone within a month. And that transparency is what's really, really important. Unfortunately, regulations in the UK are such that there are certain other things. We have standby generation, which would make your eyes water. One of our campuses has got more standby generation than is needed to power the city of Bristol. Yet, because of regulation, I can't run it when the grid is short of power, because my environmental permit won't let me because of fair emissions. The fact that I've got low emission generators, I've all these sort of things, and the impact for running for a week is not going to harm anybody. The fact is regulations won't let me. So we've got a series of regulatory systems in place at the moment that stop us being able to deploy our assets in the best way for our local community and for our people, and I would argue the planet. If we've invested in 120 megawatts of generation and it only runs for 50 hours in 100 years, guys, that's a waste of it, completely and utterly. So there is a whole lot of complexity in terms of how data centers operate. But in terms of being able to manage your energy, it's fundamental to us. And we've got to the point where every level in our system, from our HV networks down, wherever there's a switchboard, we measure our power in and out on either side of it, all the way down, and that allows us to look at what the losses are at any particular point. And if we know what those losses are and they're outside a bandwidth, we can actually go and we can go to our transformer manufacturer and say, you said at this load it would be this efficient. It's this efficient. What's the problem? That's where we want to be, because if that's the case, you can challenge what your performance curves are, and you can then put them back to the manufacturer, and they can hopefully improve them. And that learning cycle then goes all the way through the process. So, to me, if you're not managing at that level, that's fine, but you're wasting a trick. To me, the next step is integrating that into the next system, because we are so optimized in terms of how we operate and in terms of how we've been built, that if I turn this off, it will do something over here. And we need to understand what those implications are. So if I increase my water usage in here, will it reduce the power? What's the impact on my water storage system? How do I balance that? If I'm doing this, what happens if I do this and it brings a chiller on, or it brings a condenser on? Can I get away with my condenser? Because one of the biggest things we found as we were doing our greenhouse gas emissions study back in 2018, our biggest source of greenhouse gas emissions is losses from our compressors. Not by a little bit, but by 2 orders of magnitude. Our biggest carbon commitment to the planet is greenhouse gas losses, refrigerant losses from our condensers. How do you get rid of them? Managing those are all challenges that we're looking forward to go to. But if you aren't monitoring and measuring each of these things, and it becomes much bigger as you get bigger and you need to focus, and then you need to integrate it all back to be able to get the CEO to understand that it's okay without him drilling all the way down to the lowest meter, and that bit is the next challenge that we see, is how you optimize that in. And there are great things here we're doing that.
And so Pip, can you tell us maybe what's been the journey so far in terms of your power utilization efficiency from your first designs to the current ones? And what have been the key elements of the solution that have enabled you to get there?
Okay, so our PUE, power utilization effectiveness, the first data center we built, that I built in 1998, was about 1.4, 1.6, 1.4. We then made a wholesale transition and led the UK market into direct fresh air free cooling. So we use outside air through a bunch of fans, clever filters, evaporative cooling, and our PUE, operational PUE, is around about 1.2. And you can't get any better with the laws of physics, for the simple reason I've got one set of fan blowing air around, I'm reusing my waste heat when I can, I'm evaporating a little bit of water, so the pumps I've got are about this big, tiny little pumps evaporating water into an airstream, and that's been our biggest driver. The downside of that was that I had to have compressors on the top to be able to do DX cooling when the weather's really hot. By getting customers to widen their SLA up to 32 degrees means I can take the DX systems off the roof, takes the DX systems off the roof, cuts my power demand, but more importantly, in my case, cuts my greenhouse gas emissions. So those are the main steps, and then on the way we've had the normal change. We were the first to basically deploy HVO in all our sets across all our campuses, which we did in 2022, and that has cut our carbon from our standby generator planning and testing by 95%. So all of those things are what has driven our journey to get to where we are.
Yeah, that's great. Maybe turning to you, Matt, can you comment in an environment where maybe you don't have that amount of expertise, in-house? what have been those concrete things that you've already been able to achieve, and what have been your recipes?
Sure, so we've recently gone through a major energy efficiency as a service contract. We went out to tender, being a public organisation, we have to. We've gone out to the market. We're coming to the end of the installation phase, which will see the rollout of 23,000 IoT sensors, BMS upgrades across 25 of our most energy intensive buildings on campus. It's the first pilot of this size that we've done in one go. It's a multi-million pounds investment from the university side, but that we are aiming to deliver a 5% reduction in carbon emissions compared with our baseline in 2019. So hopefully be in a position to talk a little bit more about that project and the achievements or shortcomings on that project over the next sort of 12 months. I think what that project has helped us do, though, through the data that is being generated, not just through those IoT sensors, but also through various additional connected devices that are now deployed in the field, we've been able to draw insight with support from our partners to analyse where we think we might be able to make decisions and take action on the back of that. Some of the decisions that we've taken today are quite radical for a university like ours. So it includes closing down and mothballing some of the buildings that we feel are not performing well and are actually a burden to the wider estate. So there's a whole cultural change piece there around how we take out the services and the professionals that might be working in that space, be that research and academic colleagues that use the building for research purposes, be that academics that are delivering teaching and learning, maybe moving those out of that particular building, putting them elsewhere on campus, sweating the assets elsewhere. By mothballing certain buildings on campus, we've been able to deliver a material saving close to £1 million against a utility bill for this year. So that is a material saving that we've realised this year. That's only been possible, though, because of the investment in the digital technologies and the integration to connect those technologies together. Had those technologies not been connected, had they not been digitised, had they not been integrated and the data aggregated to a point where we're confident in what that data is telling us, I don't think we would have moved so quickly to make those decisions, which are really quite radical and come with it their own challenges. As a result, I don't think we would have seen that saving being realised this year, which would have presented a financial challenge back into the wider department. So from an innovation...
What do you would be your next steps then after that? Now you have all these data collection and handling systems. What do you believe could be the next steps in your journey?
Well, I think the first step is to decide what we want to do with those buildings that have been mothballed. Do we continue to invest as part of our retrofit program? And that might be investing in the fabric from a sustainability perspective. It might be upgrading switchgear. It might be modifying the BMS that's in place to bring it up to standard and to modify it in line with modern standards. There's a whole conversation piece that we need to work through to inform the planning process before we make that decision. Of course, we may decide to repurpose the space to see if actually repurposing, reconfiguring the spaces within brings with it greater utilisation, but that's something that we still need to work through. That said, I think what this experience has given the university is we've been able to address some of the questions that were being asked previously around what value is investing in digital really going to provide for us. From a traditional sense, my leadership team are very comfortable investing in bricks and mortar. We can see it, it's tangible, the benefits have been tried and tested, but when it comes to some of the more innovative digital technology, clearly there's work that's needed to bring people with us on that journey. I think this pilot, though, is great testimony to the value that can be delivered if done in synergy and in partnership with the right people. So I think continue to invest in these solutions, scaling up some of what we've already delivered as part of that initial major efficiency upgrade program, and looking at the other 175 buildings that we've got under our portfolio.
Thank you very much, Matt. So James, if we're talking about your facility, so we understand that it's very fast evolving. That your power draw from the ships, limited from the grid, are becoming more and more of a constraint. So in that very fast changing environment, now that you already operate power nearly in real time, so what would be your key next steps that you'll be taking to be able to meet ever-growing sustainability goals while securing the efficiency of the overall port operation?
Sure, I think we need to continue our rollout of digitalization of the network in our buildings. I mean, we've only probably upgraded 20 to 30 substations out of the 80 that we've got in the port. So we're still running transformers that are from 1930s, 1940s. So we've still got a lot of work to do to continue that rollout to upgrade the transformers, the substations and lighting, and all those sorts of things that everyone knows they need to do. So we've still got a long way to go there yet. I'm not saying we're done and we're the modern port, but we're definitely on our way to that. And I think having that metering and installing that metering, we've done it at our primary substations at the top of our grid, and we're now slowly starting to work down that grid and do our critical points. That metering before the transformer, after the transformer, on those high-level circuit breakers, we're now being able to see real data of where our energy is going in the port, because before we were making educated guesses, if you like, based on meters that were at cruise terminals or at a pumping station. But now we've got that at a high level, we can see exactly where our power's going in the grid. And then we've recently just done a project where we've rolled out metering across onto our power operations and our power management expert for all of our PV and all of our cruise terminals. PV's been a real insightful one because we've got that problem with grid and we don't know exactly, well, we know where our capacity is, but we didn't know really how much we were using because we had a PV system, we had our shore power system, we had our cruise terminals, and we had lots of different systems for each one. And we could see what they were using, but they weren't quick enough or live data to say, right, today we're using 10 megawatts. So now with our PV, with our grid, we also have a geothermal company connection that feeds in, and then we've got 3 different docks. So now we can look at all of our cruise terminals, look at our shore power, look at our PV, look at what we're pulling off the grid, what we're pulling from the geothermal, and we can say, today, we are actually using X. Because when a cruise ship comes in and maybe a larger one wants to plug into shore power next time, if it was the middle of the summer and we had a good PV day, we were thinking, oh yeah, great, we've got loads of capacity to come off the grid. But without that information and knowing exactly where we were, again, we were making an educated guess with a margin for error. Now we can confidently say, yes, we know we're using this, therefore we can reduce our margin of error as an engineering term to say, we know we've got that, we can deliver a bit more. But also with that metering that we rolled out across our cruise terminals, it was really interesting. We've got one cruise terminal that's brand new, and we've got another cruise terminal that's 30, 40, 50 years old, exactly where the Titanic sailed from. But it's been redone up a bit since then. But we've got a wide range of cruise terminals, and it was really interesting to see that one cruise terminal that's only 10 to 15 years old, got a brand new BMS system in it. It was really interesting to see that the BMS system was telling us it was turning off the lights in the night, it was telling us it was ramping down the HVAC. But once we installed the meters on it, we could see that it wasn't quite doing that to the extent that we thought we were. So now we're just about to roll out a project to upgrade the BMS system and fix those faults that we found because of that metering. And we didn't know that those problems were there. So that's probably going to save us about 20% over an annual cruise season.
Lot, right?
Yeah, for that one building. Yeah. So again, like Pip says, if you don't have the metering, you don't have the real evidence to prove exactly what's happening in those buildings.
I've got a very interesting example. It basically involved a £600,000 electricity bill that would have been a hit for us if we hadn't made provision.
I hope it's not for your home.
No, okay. Not for my home, be clear. But what happened was one of our MPANs, the grid supply meters, went offline. And our supplier didn't tell us it had gone offline. And I got the electricity bill at the end of the month, and I looked at my meter downstream and I thought, I'm 1.5 megawatts down. What's going on? And we ended up over about 3 months having quite a row about whose meter was right. Their meter which read nothing, or my meter which read a lot. And I was able to say, listen guys, I know exactly how much electricity I'm using because I can see it all the way down to here. Your meter isn't working. The missed billing that they hit us was £600,000. And if we hadn't identified that, when they discovered the bill was actually under billing, under legal UK law, they could have come after us and said, actually, you used £600,000. And if I'd gone to my CEO and said, we've got a £600,000 bill right now, I would probably have been shot. So, being able to understand how you're using it and reconciling it to what your supplier is charging you is fundamental. If you're not doing that, you're missing a trick.
And I think that's, we've had exactly the same thing, Pip. Yeah. So, the 4G modules that are in these meters drop out all the time. So it's something, to have that check meter underneath them is absolutely critical, because we would have been hit for a bill for about £1 million. Yeah. So it's really, you've got to have those check meters, because the technology and the 4G that's in these meters just isn't reliable enough to
this was both of the check meter and the main meter in the supply had gone, so I was relying on my own meter.
Yeah, this is it.
So sometimes making savings actually is not that difficult, right?
Exactly.
No, that's it.
But important, so.
Yeah, 100%.
All right, so it's time that we go towards a wrap. So, thanks a lot first for being our esteemed guest on this panel. So I think we heard you loud and clear about let's say more and more complex environment where you need to first understand well your facility and how it's consuming power and energy to be able to understand, change, evolve, plan for the future, long-term strategies, and automate more and more of the behaviors. We heard about, I think the skills is an important piece of it as well. Yeah. So bringing probably more out of the box capabilities and way to experiment with where the expertise is lying, to be able to build the solutions which are custom made for a given facility.
Yeah, I mean, we're talking about electrical engineers needing a certain level of knowledge and capability to manage some of the digital components that now come part of any modern BMS, switchgear, you name it.
I'm sure you'll create very great electrical engineers for our future out of the University of Birmingham.
As a university, we're certainly working towards that.
We still need people understanding electrons, not only digital, right? So both together. So really appreciate your participation to this event. I will welcome all the participants to the sessions. First, to visit our booth, you will have over the building space, the data center space, the grid space, some of the solutions we are talking about, which is around sustainability, management of power flows, bringing green electrons into processes which may or may not have flexibility. We talked about evolution of a facility, how to plan for evolution and what solutions are available for modeling a facility and be able to emulate the behavior of a facility in real time, but as well to plan in the long term. What kind of upgrade of infrastructure are necessary to be able to meet the, let's say, accelerating needs of changing the infrastructure along the way. So with that, I think we have just a couple of minutes. If some of you in the audience have some questions, we can take a couple of questions quickly, and then we'll leave with a few closing thoughts from our.
I'm just going to add one little thing in there. With us, power on all the time is an absolute essential. And so therefore being able to model the impact of a switching schedule before you do it, and actually getting somebody to practice doing that switching schedule, because in a data center, the only time the engineers really get a chance to practice is during construction and during commissioning. Once it's operational, there's no chance. And so actually something like ETAP that allows the guys to practice the switching with a digital twin makes it so much safer. And to me, that's a really big, important part of our business, being able to model how it's going to work without it actually impacting anything. And then knowing how it's going to work gives the guys confidence. And when you're doing that in a critical switching sequence, if you don't have the confidence of it going, that's when it goes wrong.
Which gets back to the skill sets, issue where I think guiding the operator in their operating the facility on a day-to-day basis. There are some solutions already available to help with that. So, So thanks a lot to all. I think it's time for a wrap. I want to really warmly thank you again for your presence here, crossing the channel in a crew, on a cruise ship, hopefully.
I wish.
Or maybe
what I can do
back,
next time.
you'll get an invitation. Thanks to our audience for participating, and so we'll stay nearby. If you have some questions, feel free to come to us, and I'll be happy to take your questions. Thanks again, have a great afternoon, and see you soon.
Thanks all.
Thank you.